everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we're examining how Agentic AI is resetting the internet as we know it, shifting focus from bandwidth and uptime to data quality, service resilience and end-to-end assurance. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Today, we're chatting about Agentic AI and its impact on network infrastructure. To start, give us a quick overview of Agentic AI, Mike, and what makes it fundamentally different from previous generations of AI or automation.
We're talking about Agentic AI, we're talking about autonomous software agents. So these are agents that are capable of making decisions and executing tasks on our behalf. So we're not talking just about chatbots or recommendation engines. These are digital actors, so they can complete entire workflows. They're taking their place as digital citizens, and they're sort of acting, deciding, and transacting at machine speed. So where we had a normal operation system there, these are sort of operating 24/7, and they're participants in the internet ecosystem. So they're not just tools, they're not just actioning predictive workflows, they're actually going through and making these decisions. So distinguish that from AI and automation in the past. You effectively had these tools that assist humans. So they add on to the system. You ask a question and they answer, and then you take action across there. Whereas when we talk about Agentic AI, so these are digital citizens, so they act autonomously. You set a goal and they figure out how best to achieve that. So they dynamically determine their own paths, they make decisions, they handle the exceptions there. And because of this, they can span multiple services, so different APIs, different data sources, all without human intervention. They're making that decision to go on. So for example, if we were looking to search a flight, we wouldn't just say, find me flights, but we say book my entire trip based on my preferences and handle any issues that come up from there. So we think about this in the context of the infrastructure and network itself. These are now users that sort of run alongside the human users themselves. So these are digital citizens that don't sleep and they don't slow down, but they create these complex independent workflows that aren't easily predictable.
Can you share examples of how poor data quality could impact the decisions and actions of AI agents in real-world scenarios?
So when we think about this, we actually think about orchestrating the entire ecosystem. So we have to have validated data, we've got to have resilient paths, and we've got to have this dynamic capacity that comes around there, which then means when we're thinking about this from a metric perspective, it's not so much a question of just, is it up? We've got to say, is it right? Is it fast? And can we actually trust that data? So we put that into a case of a financial institution. So in this case, we have an AI agent validating thousands of transactions across multiple banking systems. So if we think about all these different paths that we can have there, these dynamic transactions that have to take place, one delayed or corrupted data feed could actually equal sort of a halted trade or compliance failure, or actually miss a fraud. We failed to retrieve some part of information because it either timed out, or we didn't get it in time, or we're acting on invalid data, so we make the incorrect decision. So therefore, then the actual overall task is failed.
What strategies should organizations adopt to validate data quality and help ensure trustworthiness, especially when dealing with numerous external data sources?
So data quality is actually critical. It's not a nice to have, it's a necessity. So if we're thinking about AI agents that depend on these data feeds to make decisions and automate these processes, any one part of the bad data can actually have significant consequences. It can result in financial losses or compliance failure. So, for example, the financial service agent with that corrupted data could mean the halted trade or the missed fraud. So it's not just about the data, but better data that agents can trust to act on. So then if we have sort of validation points or validation requirements we're looking for in an agentic AI system, we need to know what the data is. So there's accuracy and completeness. So do we complete the actual flow we go through? So do we complete that service? We need to know where it came from. So provenance tracking. Can we trust this source, where we actually retrieve this data from? And then the validation itself. Is this data accurate? We can actually use it to make a decision. We take all those three together and they combine can lead to an automated action.
How do you go about validating data for AI agents?
So if we're thinking then of sort of how we validate that stuff there, we've got to have sort of data freshness checks. So how current is each source? Are we retrieving data from 1989 or prior to that? Is the information we've got about a price or the information we got from there, is it up to date? How current is each source? And then that cross-source verification, do multiple sources agree? Because also we're not necessarily always going to have this agent, or it won't necessarily check that from just one source. It might verify it across other ones. So you build that into that process. When we're checking this weather condition, or when you're checking this system, can you confirm this price from different sources? But also then this sort of fallback hierarchy. So if your actually primary source fails, what is your plan B? So what you don't want it to be is, I couldn't get the data, or I couldn't verify that data. I'm just going to use what I've got, and I'm going to run with that, because that's when we lead to this failure in the chain. We've got this type of information itself. So having all those conditions together, then what we think about, if we think about the SLA, we thought about SLAs prior to this. We're thinking about this consideration where we have loss rate for a particular circuit, or we're having a performance-based SLA from there. Availability was what I was desperately searching for. We've actually got to shift from that, because an availability system, if we think about those validated sources or that data sources we're taking from, just being up and available is no longer sufficient. We've got to now to be able to have an SLA that ensures data is not just available, but it's current and it's validated and it's trustworthy. So this then goes to this completion rate. And it isn't just were we able to book the flight, but were we able to successfully book the flight and got the flight we want, for example, in that very simple scenario itself. So because all of these data come across it, we want then to have this SLA to reflect what our outcome is. So we're not just looking at that performance, we're looking at all these data combined.
In some sectors, such as web publishing, NetOps teams may previously have downgraded or even blocked traffic coming from automated crawlers. But now, with the rise of AI agents, I imagine organizations have to sort valid non-human traffic from types they'd still like to avoid.
So if we think about traditional crawlers, they are mostly extractive. That is scraping content, often for search indexing. AI agents are transactional. What I mean by that is they're actually doing things. They're placing orders, they're checking inventory, they're validating information themselves. So they're acting as representatives of real users and business, so not just collecting data. So they're operating with complex workflows. So they might touch multiple APIs and services in one session. You can't just block these straight away anymore, because it might be a legitimate customer sort of doing the interactions. But you need to understand whose agent it is, what is it they're trying to do, and actually, is it authorized to do that? Validation about the intent and capability is not just about identifying this is bot traffic. You got to sort of understand the rate limits. Is it allowed to do this? If it comes from this location, is it allowed to do that? How many queries is it allowed to do? How many times can actually go back to the well to get information? These types of things. So the validation challenge we're talking about here is multidimensional. So first of all, you have to track provenance. So which AI service and on whose behalf, which is then the authentication. Now, whose agent is this itself? And then authorization. What is it trying to do? And is it authorized to do that? And then this may then sort of come down into the commercial, the economic side of it. Sort of, does it have sufficient quota or credits to actually do that? If we're thinking about retrieving this information, the API calls themselves aren't free. And if we're getting all these agents to do that, then it's there's a cost involved to do that. So then you also said is real-time quota checking and the billing validation. Is it allowed to do that? And all of this has got to be balanced with the security and accessibility. Effectively, I don't want to slow this process down while I'm checking it, or I don't want to stop a process there, because although I might have these fallback systems when I go from there, if I actually have information I need somebody to actually use, we obviously want people to use that, just as long as they're actually sort of coming to the right area there.
Do you think we might end up with a system where sites have a split design, one for human visitors and another for AI agents, because they have different needs?
Yeah, absolutely. I mean, if you think about a user coming to there, we want a browser front end or website that's going to attract us in and is a simple workflow. And to a lesser extent, that doesn't matter when I'm thinking about it from an agentic perspective or an agent perspective. I just want to get to the data. So yeah, absolutely, we sort of split that. And whether that then goes to a back-end system where we can have the quota checking, or we can actually charge for that data itself, it is going to change. And the reason essentially is, these systems are starting to sort of pop up around there. And we're doing it to a degree with API calls. So if I have a developer front end, I'll make an API call to a particular service. I'm not going through the front end. I'm going to the developer tools to actually get to that. That's essentially just an evolution of that. Does that mean that the front end web disappears? I don't think so. I think that remains because, as I said, the human still exists. We want to go and sort of check and validate this information. But maybe the content and some of that in the back end, maybe that kicks off a sub-agentic system that actually goes and does this and retrieves this data. So it's actually already and sort of pre-fetched to a degree when we start to come in there based on user patterns. But yeah, I can quite easily see that split happening.
Tell us more about the concept of service resilience. What are some of the biggest challenges that enterprises face when it comes to service resilience in an agentic AI world?
So the service resilience has sort of fundamentally shifted from keeping the systems up to ensuring the AI agents can reliably complete their missions. So we talked about this concept then that we have workflow completeness. I need to be able to complete the task we're actually doing. Can't just sort of time out, or I can't miss information out or jump something around there. If I think about that, then unlike a traditional workflow, which has fixed paths, the agents themselves decide their own approach per task. So this then creates more complex dependencies compared to what we'd consider from a traditional service architecture, which effectively sort of has these spreading out dependencies, but they are coming from a mesh scenario. I could have mesh on top of a mesh on top of a mesh. And then the sources the agent's going to tap into are going to vary by action. So I'm not going to have this predictable path. I'm not always going to go from A to B or A to C. I'm going to sort of mix around because there's parts of it I'll need information from, parts of it I don't. And because of this, you can't actually monitor this with traditional single point metrics anymore.
Could you explain the concept of end-to-end capacity planning in the context of agentic AI and how it differs from traditional approaches?
If you think about a traditional approach, we had, do you have enough bandwidth and do you have enough compute? Can I get to the system? Can I run what I'm actually going to do there? And if we think about the agentic AI reality, we need to think about that entire service delivery chain. We don't know necessarily where each part of that service delivery chain is going to be. So it's not just about raw connectivity. It's every step from data source to the agent, which could include the validation layers, the payment gateways, the edge computing nodes, and effectively all of it together. So how that differs then from the traditional, because we've often talked about a service delivery chain, but essentially, even though they were arranged in a mesh, we knew the components were involved in that service delivery chain. Now, these can actually sort of be dynamically allocated, as it were. So we don't necessarily know which service or which tool I'm going to call to complete a task because it's making decisions where it's going to go. So with the old model, you could effectively, let's go right back in time. I could throw bandwidth at a problem. I could just up the bandwidth and then everything would actually work around there. Then we moved to distributed architecture. And effectively, we could increase our bandwidth, but we didn't control the entire path. But we still had an idea of where our services were, these dependencies where we're actually going to. We knew we would go from here to there. If we had a particular latency requirement, we could actually move a CDN there and we have bandwidth coming into that one there. Now, if we're thinking about that, we sort of added to that again. The agents now create complex multi-hop workflows that touch dozens of services. So the bottleneck can be anywhere in that chain, and any slowdown can compromise their entire operation. So not only do we not control these components or this bandwidth in between, but also we don't necessarily control the compute side of it. We do not control the path we're going to go from. We don't know which path we're going to take to actually service that particular task itself. It could be sort of anywhere on that journey. So if we think of that from a bank perspective, so the bank's back end is supporting thousands of customers, their queries and sort of regulatory checks per second. We have to do that. So it's not just about buying more bandwidth into the main data center itself. We need to optimize every single link. So we need to be able to sort of understand the model usage patterns so you can understand the spikes. So it's ensuring there's no single bottlenecks that can sort of slow everything down as we go to that process. So think about streaming services. They preload popular content to the edge service based on anticipated demand. Now, this is a similar concept for the AI agents, but with a key difference. The agents are going to choose their own path. So we're working with probabilistic predictions where we're analyzing historical patterns to anticipate the likely agent behaviors. So therefore, we can dynamically allocate resources based on those patterns, even though we can't predict each path. So the goal essentially is to ensure this seamless performance even during these sort of unexpected surges that take place.
So finally, how do NetOps teams need to think differently when it comes to agentic AI?
This creates this shift in the mindset. So we've moved from how much capacity do we need to how do we orchestrate capacity across this entire service delivery chain. So it's about understanding and predicting as much as you can the likely agent behaviors and pre-positioning resources accordingly. So this end-to-end view, every dependency, every hop, every potential failure point needs to be sort of understood where it can actually be so that if something does go wrong, we want to be able to see where it is. But more importantly, you can actually start to optimize that delivery. So this capacity planning then becomes a continuous predictive exercise rather than just a periodic procurement decision. So where what you're doing essentially is you're planning for intelligent workflows, intelligent networking, not just traffic volumes.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send us questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.